All right, guys, part 2 of inverse functions. In the part 1 video, we looked at finding inverses given either a graph or a table of values. In part 2, we're going to look at, given an equation, how we find the inverse function. And we're going to do that by swapping our x and our y. So x becomes y becomes x, and then we're going to solve the equation for y. So let's see what that looks like. So in our first problem, we've got f of x equals 3x minus 6. And again, we're just looking for the inverse today. So to find the inverse, remember f of x means y. So we're going to replace the f of x with an x. We're going to replace the x with a y. All right, that's our first step right there. Now all we have to do to get the inverse is to get y by itself. And so just like you would have done in Algebra 1 when you were solving for x, now we're just going to solve for y. And so we're going to do that by adding 6 to both sides. And then to get rid of the multiplying by 3, we're going to divide by 3. And you could divide the whole, like the right-hand side all by 3, or you could divide them individually, both by 3. You get the same thing. And those 3's are going to cancel. So that gives us x plus 6 over 3 equals y. So this is our inverse function. And because it's the inverse function, we're just going to change that y. Originally it was f of x. Now we're just going to call it f inverse of x right there. And so that's our inverse function. Second problem, given g of x. So again, g of x means y. So we're going to replace g of x with x. And we're going to replace x with y. Now we're going to try to get y by itself here. So to do that, anything outside the square root gets moved first, so we're going to divide both sides by 2. All right, those 2's cancel. And so that gives us x divided by 2 equals the square root of y plus 1. Now we can't move the plus 1 yet because it's underneath the square root. And so to get rid of a square root, the opposite operation is to square both sides. So we're going to square the right-hand side, and we're going to square the left-hand side. And these, again, these are opposite, so those do cancel. So our right-hand side is just y plus 1. And our left-hand side is x over 2 all squared. All right, all we have left to do now is to subtract that 1 over. And so that gives us x over 2 squared minus 1 equals y. And again, we're going to change that y back into f inverse, since this is the inverse function. Now, this is correct, and it might be how the answer is written. Or we could view this as x over 2 multiplied by itself. So if we're multiplying x over 2 by itself, the x would become an x squared. And then 2 times 2, that would give us 4. All right, so the answer could also be written like this, right there. Oh, that was g of x, wasn't it? So let's call that g inverse, not f inverse. G inverse instead of f. All right, 2 more. So same idea. We're just going to find the inverse function. So swap h of x out for x. Replace x with y. Now, y is in the bottom of the fraction. And so to get y out of the bottom of the fraction, we're going to have to multiply both sides by that y plus 3, by the entire denominator. When we do that on the right-hand side, these are going to cancel. So we're just left with 4 over here. On the left-hand side, we've got, again, y plus 3 multiplied by x. Now, you do have the option to distribute the x here, but it's going to create a little bit of extra work later. So instead of distributing x, I'm going to divide both sides by x here, just to move the x away from the y. And so those x's cancel. So we're just left with y plus 3 on the left. And then on the right, we have 4 over x. And then our last step, subtract that 3 over. And we're going to replace the y with h inverse of x. All right, that's it for that one. And then the last one, this one's a little tricky. So we've got multiple x's, so we're going to have to replace each of the x's with the y. So we're going to start by replacing j of x with x, replace both of the x's with y. Now, we've got a y in the numerator and a y in the denominator. So we're going to start by moving this y minus 2 to the other side. All right, so we're going to multiply both sides by the denominator. All right, these are going to cancel. Now, on this question, it didn't make sense to distribute the x because that was the only y in the problem. But because there's a y on this side, I can't just divide this over because it's going to then be on the same side as y again. So we are going to go ahead and distribute here. So if I distribute x, I'm going to make that y times x, or just I'll put x first, xy, then minus 2x equals the right-hand side is now just y plus 1. All right, so this equation has 4 terms. 2 of them have a y, and 2 of them do not. So the terms that don't have a y, I'm going to move to one side. And the terms that do have a y, move to the other. So I'm going to add this 2x to both sides. All right, so those cancel. But now I want to move the y over to this side, so I have to subtract that over. And so that's going to give us x times y minus y equals either 1 plus 2x or 2x plus 1, same thing, like that. All right, so we got the y's on the left. We got the terms without a y on the right. Now we need to factor out the GCF of these two terms, which is y. And so if we factor out a y from both, the first term just becomes x. The second term becomes 1. Remember, GCF factoring is like division. So when you divide y by itself, you're left with a 1. And this is going to equal the right-hand side, which is 2x plus 1. Now, the reason we factored out that y is now this grouping doesn't have a y. And so if we divide both sides by x minus 1, that gets y by itself. And again, all the x's are on the other side. So now we just replace y with j inverse of x. All right, and that would be our inverse function. All right, so that one's pretty tricky. The other 3 aren't too bad. We'll do a mixture in class, but again, the difficult one, we kind of view it like extra credit, but that's how you would do that one. All right, guys, stay flawless.